Hello, this is Dr. Mears, and today we are going to be learning about the quotient rule to differentiate functions. So here we have all of our dy and dx's, and what this whole thing means is that we're going to be taking the derivative of the quotient, and that is going to be equal to the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator, and then all divided by the denominator squared. What does that mean? Again, I think this is easiest when taught through an example, so let's look at the example. So what I'm going to do is I'm going to assign two variables to these. This one is going to be my u, and this one is going to be my v. And I'm going to follow along with this pattern that they give us. So in order to take the derivative, first I'm going to write down what my v is. So remember, the denominator is the v. And then I'm going to take the derivative, the d, derivative of the u, which is going to be the numerator. So let's do that first. So dy over dx equals v, 3x minus x squared times, now I'm going to do the derivative of this one. So the derivative, and if you do want to do it on the side because you like setting it up, so the derivative of u is going to be 2x, and then the 3 drops out. And then if you want to do the derivative of v, I know some people like to do this on the side, so it just keeps everything nice and simple, and they just can look at it and say, oh, I have my answers right there. The derivative of 3x is 3, 2 times negative 1 is negative 2, 2 minus 1 is 1. Okay, so I wrote down my v. Now I have to take the derivative of u. I have that, that's 2x minus u, x squared minus 3, times the derivative of v. I have that. 3 minus 2x, all divided by v squared, so I'm going to take this one, squared. Okay, so now that I've followed along with this pattern, the derivative has been taken, but I'm going to clean it up a little bit because there's a lot that I can combine here. So first I'm going to start with distributing the 2x to the 3x and the negative x squared. 2x times 3x is 6x squared. 2x times negative x squared is negative 2x to the third. Okay, then what I'm going to do, and this is going to be, I'm going to keep my parentheses, minus, I'm going to multiply this out. So x squared times 3, 3x squared. X squared times negative 2x, negative 2x to the third. X squared is done. Negative 3 times positive 3 is negative 9. Negative 3 times negative 2x is positive 6x, and that's done. All divided by, don't forget your denominator, 3x minus x squared squared. Okay, now what I'm going to do is I'm going to distribute this negative, this is really, remember, a negative 1 here. I'm going to distribute that out so I can get rid of my parentheses. So dy over dx equals 6x squared minus 2x to the third. I can drop these parentheses because these are going to be dropped once I distribute this negative 1. Negative 1 times 3x squared is negative 3x squared. This changes to positive 2x to the third. This changes to positive 9. This changes to negative 6x. All divided by. Okay. Now what I'm going to do, you see it, combine like terms. So let's combine some like terms. Okay, so we have, and I just want to make sure I have everything correct here. Yeah, okay. So we have dy over dx equals, now I'm looking for my highest exponent because I want that to go first. So I have a negative 2x to the third. Ooh, and I have a positive 2x to the third. So guess what? Those drop out. Love that. All right, I have a 6x squared, and I have a minus 3x squared. So that's going to leave me with a 3x squared. Out, out. I have a minus 6x, and then I have a plus 9. All divided by 3x minus x squared squared. Now, I could multiply this out, but I'm not going to. I'm just going to leave it. I could even factor a 3 out here, but nothing would be crossing out, so I'm actually just going to leave it. So this has been the quotient rule using our pattern up here of taking the derivative, and then after we did that, most of the work, this part was simplification and making it look a little bit neater. Hope it helped.